Okay, hello, Dr. Schweiger. This is my presentation. Start screen recording. Let's see. Share screen. Okay. So hello, my name is Aditya Bora, and I am the founder of Hololenz Solutions. So the problem statement. We work for Hololenz. We've been tasked by a client with developing a 3D eye tracking algorithm for use in holographic display applications. So about us, as I mentioned earlier, we are HoloLens. We develop low-cost 3D eye tracking solutions using different advanced machine learning and computer vision techniques. The solution we've developed is capable of working with a standard webcam and capable of porting values to a 3D simulation software such as Unity 3D. So this is our flyer. This tells you a little bit about our company. It's got our got a little description about what we produce, contact information, our address, and where you can reach us through our website. This is our logo. I designed this logo to try and encompass all the different aspects of our company. As you can see, there's 3D in the background, and then we have an image of eye with two arrows pointing out, and you'll see the resemblance to our project, as I'll explain later in the presentation. Part of our company, we also have a great website where you are able to learn more about our product and a little bit more about our company and contact information, as well as viewing our different documents. And so that'll be available. And I will also demo that website at the end of the presentation, just because Zoom is a little weird with the screen recording. So we're a company based on research, and so we looked into different aspects of the market we're about to enter. And so I'll give a little bit of a synopsis of the research that we performed before we worked on developing this product. So operation application, the display which is being used in this project is called a looking glass. This holographic display is capable of rendering objects and videos in 3 dimensions. And so that means that unlike a traditional display or monitor, which you're probably watching this video on, you can actually render a 3D object. And as you move around the object, you can see different aspects of the scene or the image that's being rendered on this display. History and current events. So a little bit about the field of holographics. And so the field can kind of be dated back to 1947. It's an interesting process as to how we have gotten to the point of the holographic technology that we have today, such as looking glass. One of the influential people was Dennis Gaber, and he was looking for ways to improve the electron microscope, and he coined the term the holograph. And then another really big revolutionary development in the history of this technology was the laser, which was developed in 1960. So these are just like a few of the like basics of the history of technologies which have played a big part in allowing the holographic technologies that we have today to become a reality. Currently, certain concepts in the field of anatomy and medicine are difficult to explain. For instance, if you have if you're trying to explain something regarding the jaw, teeth, or possibly a certain section of an organ, those things are hard to display in 2 dimensions. So that's where the 3-dimensional display comes into play, and that's why having this display is really important. And I will explain a little bit about why this technology is really important as well. Further in the presentation. So the device that we're using today is called the looking glass. It was invented by Sean Frayne. He's a relatively young guy who studied physics at MIT. And so he wanted to create a display which used this new optic technology called light fields to be able to create these holographic projections. So obviously the reasons for choosing this design, they met all the necessary criteria and design constraints, and they also would allow us to accomplish the task of our client. So bill of materials, this project is relatively less heavy on the fabrication side. It was more just connecting some basic electronics together. We use a Logitech web camera, 2080 NVIDIA graphics card, which is running on a gaming computer, and then we also have the looking glass holographic display. So the fabrication, obviously all the materials were purchased by myself. There was minimal fabrication in this project. Some stuff included like plugging in the display into the computer and making sure everything had the right source of power. So the main calculation which was needed for this project was calculating a scale for which the eye tracking output on the computer could be converted to real world coordinates. So in other words, what that means is the eye tracking algorithm would predict that a user is looking at like a 3D coordinate of like 0, 1, 3, but we need to be able to convert that to like how to like a real world coordinate in terms of like 2 feet in front of your face, 3 inches to the right, and 4 inches, 4 inches, say, up or down. So we just need to be able to like translate the output of the computer to like a output on like a real world coordinate system. So final product, live video feed is captured by the web camera. This video feed is then accessed in Python. We use deep learning to make predictions on a series of 3D coordinates. So the testing process was conducted with me as a testing subject. Ultimately, the main part of this project was trying to ensure that the algorithm was accurate, even though that wasn't necessarily a design constraint. Obviously, the more efficient it is, the more application it has. One of the problems I faced was that this algorithm is relatively computationally intensive, and so programs would take a long time to start to optimize it to ensure that it was working properly. And then during testing, I basically concluded that with the setup that I had, determining where a user is looking on a more macro scale is relatively easy to determine whether you're looking left or right, but determining how close or far the depth of a person's gaze on a micro scale is pretty difficult. So this was one of the results I faced, or I concluded. So in the future, I would try and use more higher quality web cameras to track eye movements. Okay. So now I'm going to give a rundown of our website. This is our website. Go to the home page. Tells us a little bit about our company. We develop low-cost eye tracking solutions, and then what we do. The more just a cool quote, our location, our contact information, and then of course we've got our files, which are capable of being downloaded, as I will demonstrate. Yeah, that's our final look. Okay, so this video shows me achieving standards 1, 2, 3, 4, and 8. So it shows the video which is being inputted by the webcam and then analyzed by Python and making predictions as to where I'm looking using the standard lighting scheme. And then it also has the arrows depicting where I'm looking and capable of working with minor head movements. And so this now is the Unity 3D output, and so that's allowing me to achieve standards 5, 6, and 7 because it's sending the values from Python to Unity 3D. And then the purple line is essentially predicting where I'm looking. And these are targets which I'd set up in that simulation, and it's trying to predict which target I'm looking at. So this is how I achieve all the design constraints.